Oh guys, hope you're doing well. This video is about modifying another KS0 Ultra. So I already soldered the XT60 connector like always, and it's soldered directly to another side of this board, so it's pretty good soldering method. And I've been using, but this video is not about it. It's about using this copper block. So what it's gonna do is gonna go from this MOSFETs. I was thinking to use thermal pad, but I'm thinking to use a thermal glue below there, and then put the thermal paste here, and that's supposedly gonna transfer the heat to this larger heat sink that it's a body of KS0 Ultra. I don't know, what do you guys think? Will it work? I want to put it to test. Someone posted the video on Greater, not the video but the picture how they did it on Greater Good Miner Discord, and I was like, oh shoot, this block. And they just put a bunch of the heat sinks over here on two sides right to the body, so when the air blows through, it's cooling. You have to pretty much cool down this whole heat sink, the bigger aluminum heat sink. So hopefully it will transfer heat just right there to aluminum. I don't know if that's going to be good enough from this copper, because this copper is going to get really hot. So I'm going to polish a little bit more. I had to cut it to the size so it perfectly fits. It's about 50 millimeter long, and I got a 10 mil thickness, so you could potentially get, I have another one like 6 millimeters that perfectly sits, but it's not covering completely MOSFETs. Can you see that? It's just a little bit too, I think 6 millimeters too short, but it will not touch this little, I don't know if you could see this little, is it capacitors? Yeah, I think those little capacitors, they sticking out, these little guys. So in order to pass them, I just notch 3 notches there, and it's gonna sit right over these capacitors right there without touching them. And I already done it before with the other large heatsink that I cut from the something like that, and I just did notches, and I put it on the thermal glue. So it works okay, but it still requires a lot of air to pull, and it overheats when the temperature gets hot. So I want to try this block. Let's see if it's gonna work. If not, then it's not. So I will just record this video, post it out, we'll see how it works. Yeah, need to use thermal glue first, attach it right over there, and yeah, I need to slide it over just like that, so there's nothing touching on this capacitor, the copper thing. Okay, all right, so I put some amount of thermal glue, and we will be placing this just right over this MOSFETs, and making sure we're not touching any of the capacitors and have space in between. And we'll let it dry, sit, and want to make sure there's a space between these boxes. I don't know if that's resistors or just some kind of coils on this right there. Need to get a little bit of slightly off these coils. All right, and then we're gonna push it down and just leave it right in between. Yeah, I think that's it. What do you guys think? We got this. Need to get a little bit more aligned, just like that. All right, as straight as possible. And we're not touching any of these capacitors, right? Maybe slightly push this way, yeah, so it dries in the right spot. And then I'm gonna apply thermal paste, MX6, just right over this, and it will be contacting directly to this body. So let's wait till it dries so I don't move it. while I'm putting back together. So I think it's just where it should be over these capacitors, right? We're not touching any. Yeah, we have pretty big space around, so we should be good. And we're covering every MOSFET, right? Just to make sure we don't have MOSFETs exposed. Maybe slightly going back this way. All right. I think that's it. So we're gonna push the air just in between to cool. Basically, we're cooling now these big heat sinks. It's a little easier, hopefully, to cool, but I don't know. Let's see. Let's wait till it dries a little bit. Attach this back and we'll see. All right, so looks like we got pretty well connected right there. Even have a little bit of the paste, thermal paste coming out there. I don't know if you guys could see, but yeah. And hopefully, yeah, there is nothing touching this copper. Yeah, it didn't slide anywhere, so it's good. Well, we gotta start and see how we cool down. Maybe put in some sort of heat sinks, maybe something like that over this area. What do you guys think? And just we have to blow the air somewhere here. So I don't know. It's kind of harder to cool down, but if we can apply, maybe that's something we could do. Here I need to use some kind of sticker, thermal stickers. I don't know if that's even gonna work. Anyways, that's the idea behind it, to cool more or blow air more on this side, but I'm gonna blow through because some air are gonna blow through as well. So I don't know how I'm gonna use these guys. Oh, and I need to connect fans back, so obviously I'm not gonna be able to do it, so I need to take it out and put these fans connectors, or I need spoofers. For now, I'll just use this fan back in. All right, so we applied some thermal paste, connected fan backs. I mean, those fans needs to be connected in order to miner to work, and we're gonna put this plate carefully back and tight the screws very, very carefully. All right, looks like we're not touching any capacitors. The thermal paste came out a little bit, so that's a good sign. So we apply a generous amount. Let's see how we can push the air through. There's still gaps on the sides. Need to really cool down now this big heat sink. And this time I'm connecting to this basically PC PSU, just from the regular PC from GPU mining. And I created this custom cable to XT60, and we will connect to the miner. Sorry, I'm using two hands. All right, right there. And looks like we got the blue light, and let's connect to Ethernet cable right over here. Okay, we got the Ethernet. All right, guys. So I'm gonna be blowing the air with just 1200 CFM right on this. Somehow cool down this heatsink. So we'll see how it will. Yeah, just a little bit of air. I just want to see what the temperature is going to be on the. I think it's overclocked to 550 or 505 or 562 probably, or 505 GL version. So we'll see how it's gonna work out. Will it even start mining? Yeah, by the way, these fans, if anything, they need to start blowing also to this doors to cool out this heatsink somehow, this little fan, so they don't waste it. We'll see if we can use them as well, but for now they just connected, so they report, and so this could start mining hopefully within the next few minutes. There you go, that's the block. We'll we'll see how it works. For some reason not connecting yet. Maybe it'll take an extra few minutes. All right. I'm gonna keep these windows open for now so we can just figure it out. Maybe we can blow the air right inside and cool down this aluminum heatsink somehow. All right, so it looks like we should be on the pool. So we'll check the temperature on the iceriver monitor tool and see what it is. All right, so I put 550 clock, so that's a 618 GL version, low power mode. It looks like after 1.5 hours, it's still averaging around 650 gigahash, which I think is pretty good. I mean, overall like 624. So the line is not being really freaky, just holding up pretty well, I think. Sometimes it jumped here to 716, but in average over 600, I believe 18. So it performs over 618, which I think it's pretty good. You know, like we get that 72 board temperature and 52 out, which is almost about the same as the chip temperature, which is interesting because we're transferring now to the other side of heatsink. So if we're getting hotter here on the chips, it's probably going to be here on the board. But what I like to see if the MOSFET is going to hold off this temperature. And if you notice, I'm running on the regular fan, like on a small 1200 CFM. So I'm not using 3000 and I'm not blowing inside, just cooling out the outside of that body heatsink. All right, so let's, I'll show you in a second. All right, and this is the setup. So you could see this one is super quiet. It's not like 3000 or any higher RPM. And I put on these two areas those heat sinks to help. It's aluminum heat sinks with adhesive tape, thermal tape, just right over these holes because it fits perfectly there. I use them for my dash camera for honey miner, right? High mapper. So these guys are helping to cool and they're not very hot at all. So looks like all I need to cool down is just this side of the miner, so it's keeping that block, copper block inside cooler. All right, so that's our 222, the IP. So you could see that I'm working on this miner here. Now, as for power consumption, I forgot to mention, so I'm using this XT60 connector, but I switched here to two of the cables. So I'm using this regular PSU. It's pretty cool to touch, so it's not even loaded because it's 1000 watts, but I'm using that for one miner running on 505 clocks. Okay, and this second one, plus I'm using the fan connector here with the adjustable fan speed also to this PSU. And I figured out how you can use just the regular GPU cables. You have to just basically twist a little bit and it will still plug in. So this miner uses two cables. They're totally cool to touch because we are probably at around 200 watt right now based on my 618. Let's check it out on my spreadsheet. All right, so I'm using 618 clock, 618 GL firmware, which is 550 clocks, right? And on 12 volt, I'm around 196 watts, so close to 200 watts here, which that's why I doubled the cable. So definitely going to 700G, it will bring me to 241, and then 721 GL, I'm sorry, 700 GL, 248, and then definitely going down to 260. You need to double up those cables. So do not use single PCIe cable if you're mining on 12 volts, as you're gonna be starting to using more power here past the probably clocks are 562 is already kind of risky. I mean, it's kind of like a single maximum to single GPU, but 150 usually is the max what we've used on a single cable for, like, you know, 3060 Ti's, but they do go to 170, I believe, on single cable, but just kind of riskier. I think doubling the cable past this 562 is the good idea, so you kind of not, and the cables are pretty cool to touch, so I think there's no overheating. So let's try this 700 GL version, because I am right now the chip's running pretty cool. I don't know if that my fan just blowing directly to those heat sinks, but also the temperature of the chips kind of dropped here, so I'm not sure what's why is it dropping, but I think because I pointed the fan now directly to those heat sinks. So let's think it's time to switch to the next firmware. So let's go to 720 GL, since I double up my cables. And again, follow up this rule: stop your iceriver monitor or close altogether. It's recommended to close, but I'm at least stopping. So far it's working okay for me. And then I'm gonna select the file 700 GL and let's update. So I noticed a lot of time if you forget, when you upgrade and you forget to stop your iceriver monitor tool, it would say failed here for the upgrade. So if it failed, number one, check your iceriver monitor. See right there, it says failed. So even though I just closed it, all right, so I'm glad it happened, because once in a while, even if you close this iceriver monitor tool, so you see for the IP 228, I closed the wrong one, obviously, so that's the issue. Because I have so many windows are open here, and I need to open correct one right there. So this is the one with 222 IP address, so that's the one I was talking about, and I clicked on the wrong one. So let's stop this. Actually, the temperature here around 7151, so I was looking at the wrong one, which is good. So now we're gonna stop this correct one, and then we're gonna click OK. That's fine, it's failed, and we're gonna try one more time the update tool. So this time it should take the upgrade. Now, once in a while, what I noticed, it didn't happen to me many times, only maybe 1 or 2 times, when I have this iceriver monitor tool off or closed and it still failed. And what I noticed, it's also failed after I restart the miner or after I use the iceriver management tool. So even with using management tool, it still failed on me. See, operation succeeded. So this time we are okay, because we stopped iceriver monitor tool. So it's going to restart the miner now on 200. It will change to 600 clocks here in a few minutes, and we can click read after it reboots. So what I was going to say was failed message pretty much like several times. I tried to restart the miner. I didn't do factory reset, which is good. So if you do factory reset, you can potentially break your miner. So do not, if it's failed, do not rush on it. Do not rush to factory reset, because that's very last choice. So what you want to do first is, and in my case, what was is kind of weird stuff. So because I used previously a firmware, which is DF3 version, DEFI number 3, right? And I didn't actually upload firmware, but what I did initial file. So it looked like the miner it's using the original. So I'll show you just like right here. So it looked like I'm using the original firmware, because if you use the initial file, you will see exactly the same firmware, so there is nothing different about it. But if you do initial and click restore factory, you will break machine potentially. So, and what happened to me is after I had the initial file for a while, I forgot probably about it, and I was trying to upgrade to the new overclock and it was keep on failing. So I was like, what should I do? Because when I did restore, at one point I bricked before my KS0 Ultra, so I wasn't gonna do that again. What I actually had to do is find the folder and upgrade, actually do a revert upgrade from the old DF3. So all you gotta go there and use that revert upgrade file again. So even if none of these clocks is taken, even initial would fail after restarting, rebooting the miner multiple times, and then revert update is the one will be used, and it's actually will take the revert update at that point, and after that you can install any other clock, so you're basically back to factory. So make sure do not restore factory settings, this red one, or the push button on the miner for 30 seconds, because you may potentially break your miner. Hopefully that will help someone, because that's kind of important. Okay, so it looks like we are back on the, let's click here, update for 222 IP. Okay, so we are on the 620, guys. So we are using 700 GL here, and let's hope we're not gonna overheat with just using that small fan, because it's only 1200 RPM or 1300 RPM. You heard like it's super quiet, so you can use in the room, but that's my goal, is just kind of to create, if it's possible, and not using 3000 RPM or 5000 that I have to use for my other miners to run these guys. Look, it's pretty cool on yes, obviously on the board temperature, super cool, and it's running stable 3 days, 700, my 721 version. And yeah, it's just because I'm running at the 5600 RPM fans on this, but it's pretty noisy, so I have to keep in my garage, and it gets really hot there as well. So looks like it's the board temperature rising 76, but it's not that bad. We probably can go up to 80 here, and then so yeah, it's kind of rising, so hopefully it will not overheat. I will need to go and check how the fan blowing on those, and I'll get thermal camera, check it out if it's heating up that large heat sink, I mean the body of the miner. Alright guys, so I wasn't able to mine on 720 or 700 actually GL, because it would overheat. On this side I would go to 90 degrees and it would shut down, probably over 90, but I could measure up to 90. But look, it's right now, it's the maximum 79 degrees here on this side. It's on the power side of the miner. Usually I measure, because I blow in air through here, I measure to the other side, which stays a lot cooler. You could see that copper block is actually much cooler, and we only getting like 57 degrees on this spot, the hottest on the power side. So if we measure it from power side, it looks like the temperatures are lower than on this those gray boxes, see, like next to the copper block that I put, right? So that's behind those copper behind that copper blocks, all this guys getting like super hot. Look, 80 degrees, 78.5. So this is, I mean, it's not overheating yet, but it's going to the max, I guess. The MOSFET's temperature looks like maximum 120 degree working temperature, so we can't measure that, and unless we're looking in firmware, PB Farmer firmware. But anyways, this side's staying pretty cool, so the fan, just regular fan, being able to simply cool it down without any issues on 618 GL. But 700 GL for some reason just creates so much heat on that side. So it's not just the block doesn't get overheated, the copper block, and these heat sinks are staying pretty cool to touch. So I'm not sure, is it not transferring the heat fast enough to that aluminum heat sink, or what's going on there? The thermal paste I put, maybe I need the thermal pad, I don't know. I'll have to play with that. I have a piece of thermal pad, a tiny piece that I can try as well. Yeah, look, the heat sinks that I put, it's just like, it's not even hot enough. I don't know how to measure it. You can't even get the hottest spot on them because they're pretty black. They're cool. They're simply cooling with this fan. You could see this miner is a lot hotter. It's 71 degrees on the surface. And this one I was able to cool down to 65, even though these are the higher overclocks. So, oh, and this one blinking, so this probably overheated. Of course, because the fan got blown down. Okay, so I have to reset the power here. All right, so basically that's what it is. So let's figure it out how we can cool down this copper block. Maybe add some heat sinks to it or something like that as well. All right, so this is the modification. I added a bunch of the heat sinks to that copper block from both sides, and I'm gonna use tape, 1.5 millimeter tape on both sides now. Need to move this one a little bit. So I want to make sure we're cooling this. I don't know if this coils or wherever they getting maybe hot, because I'm reading like a hot temperature on this side. All right, so let me wrap it up. I need to move this a little bit away. All right, here is the final product. I have this heat sinks on this side. We will try to get all the heat from this block and transfer through the thermal paste to the body here, majority of the heat. So let's see if that's gonna help any. If not, have another option. I drill a bunch of holes trying to pull the air from another block. I know it's ugly, but same idea. I'm trying to get all the air through and hopefully cool down faster those MOSFETs. So let's see which one performs better. So I'll put this one, we'll see what's the reading, the temperature difference, and we'll go from there. All right, here is the final product. I have heat sinks attached on this side. From here I also have heat sinks attached, and we have a thermal paste between the sandwich. All right, so let's try. So I have exactly same setup, 1200 or 1300 RPM fan. You can hear it's really loud. It's a full speed. It's blowing air, but it's not like 3000 or 5000 RPM. But let's check on the web GUI after maybe 30 minutes, see what the temperatures when it's get higher. Our ambient temperature 77, so not too bad over here. So let's hope we can achieve something here today. All right, guys, so it's been over a week and I cannot get this copper block to mine, with this copper block to mine higher than 676, I believe, gigahash version of firmware. So as soon as I go to 700 with the ambient temperature here in garage, like 85, 90, it will go red and it's basically overheating the MOSFET. So it does mine with this new shroud, although I put in this new design that it just blows the air inside, right? You could see that just directly into the miner, but it only mines with the ambient temperature like below 80 on 700 GL or 721 GL version. So anyways, I have to try different block that I'll show you in a second. So I prepared this block, copper block, to go over. So I have already notches done, and I drill a bunch of holes right through this copper block. I had the couple drill bits broken because it's a little tough to drill this soft material. You have to go low speed. Anyway, that's my hope that the air, it will pass a little bit of the air through these holes, and hopefully will work better than just a solid block. Even though I added those heat sinks to that block, it's still not a good success with the higher clock. So anyways, that will be a separate video because I have to get and mount this one maybe on a different miner so I can test it out. Because when I have these regular heat sinks, like just like this, it basically works out perfectly because the air goes right through the miner. So I guess this block, well, I should take it back. So when the ambient temperature goes about 90, it's pretty hard to maintain the miner MOSFET temperature below, you know, like certain amount, so it doesn't overheat and stops the miner. So there's a different things that come to play: your ambient temperature, the how your fan speed. I'm doing the 5500 RPM. I think it goes to 5800. I have some of the 6000 RPM fans, but with this specific block, I didn't have a good luck yet with the ambient temperature being here in garage. I have other miners that mine in garage with the ambient temperature going even to 95. So maybe just my silicon here in this specific miner not that lucky on this MOSFETs. Anyways, that's it for this video, guys. I hope you like it to see this experiment. So we'll have to work out with this guy and see if I can achieve any better speeds, any better. Look how ugly it is. All right. Anyways, we'll see you on the next one.